I'd like to tell you a little bit about WHOI. Since I've gotten to know Victoria and now Bryan, we feel like ALL, it's one of the best kept secrets on the Cape. You can say to somebody, ALL, and they look at you as if, "Ooh, what's that?" And you can say the same thing about WHOI, even though they are world renowned. They are the largest independent organization dedicated exclusively to ocean research. I read the Science Times basically every week, and I rarely read an article that talks about the oceans that doesn't mention WHOI. This world-class institution boasts significant contributions to the global understanding of the ocean and exploration of the deep sea. Notable achievements include discovery of hydrothermal vent communities, exploration of the HMS Titanic, and creation of deep sea exploration with the submersible ALVIN, and revolutionary underwater robotic technology. We welcome Bryan. We know we are going to be really well educated this morning.
Awesome, thank you for coming out today, everyone. Let me know on the volume, if it has to go up, down, if I'm yelling at you. But I am Bryan McCormack, and I am the Coastal Processes and Hazard Specialist with Hole Oceanographic Institution Sea Grant and the Barnstable County Cape Cod Cooperative Extension. That's on the quiz at the end of this, so you have to remember. But basically what that means is when you are seeing problems on the coastline with erosion, flooding, you can call me, and I can't necessarily solve the problem for you, but I can give you a lot of good information to help you make informed decisions on whatever you might want to do. And today, I want to give you a little bit of the science behind the science. And I always like to start off with a roadmap so that you know where we're going and so that I can remember. But we start off with some glacial geology. How did we get here to begin with? Then we're going to move into sea level and storms, kind of how the Cape was shaped and how it's going to continue to evolve through time through the coastal processes. Then I want to dive into humans on the coast, how we interact with erosion, how we live here and deal with some of these problems, and some of the problems that we create from that. And then I want to end with some, I call it emergency preparedness here, but it's everything from what do you do during a storm to how do you protect yourself and your property when the land is just eroding up from underneath you. So this all starts with a really big ice cube. And that ice cube is called the Laurentide ice sheet. And about 23,000 years ago, during the last glacial maximum, it was up to 2 miles thick in some places. So that is 2 miles above our heads. But we are not currently under an ice sheet right now, and so we know that that ice began to melt, and it began to retreat through what we now know as Cape Cod about 18,000 years ago. And that defined the landscape that we see today. That ice sheet acts like a plow. It will pick up anything in front of it and push it and move it along with it. If you know Dome Rock, that is the largest glacial erratic on Cape Cod. It is a massive boulder. An ice sheet does not care what you put in front of it. It will pick it up and it will take it right along with it. And it also leaves behind things like terminal moraines. So some of those high elevations that we see around. And then outwash plains. So as that water is melting out and taking some of that sediment with it, it creates these nice long plains beyond that moraine. But that ice is gone. Why? This guy here, Milutin Milankovitch, he studied this back in early 1900s, I believe he solved all this. And what he looked at were 3 major processes in how the Earth moves. One is the change in the eccentricity. And so that is the Earth moving around the sun in its orbit. It goes from almost a perfect circle to a bit of an egg shape over the course of about 100,000 years. Along with this is the axial precession, or the wobble. And so I want you to think of Earth as almost an unbalanced top. And as it wobbles around, that tilt angle, or what we call the obliquity, that changes as well. And all of these processes come together to form the glacier and interglacial periods that we see on Earth. And as that ice melted away, sea level began to come up around with it. And so as we look about 11,000 years ago, George's Bank was dry land. There were people living out there. And so if you go out there today and you're fishing, you're having a great time, a great fishing spot, and you look at the depth beneath you, in some places it's as shallow as about 35, 40 feet. And it's strange because you're seemingly in the middle of the ocean with nothing around and only 35 feet of water. But it is submerged now, and that sea level continued to come up, and it left us with pretty much the Cape Cod we see today. But one of the things that goes into that ice sheet melting is the isostatic rebound. And that 2 miles of ice, it was heavy enough to deform the crust of the Earth beneath it, and as it melts away, that crust begins to rebound back up. And so if we want to calculate the gravitational I'm just kidding. What this is showing you is that ice is so massive, it has a strong gravitational force along with it. And so it actually pulls a lot of that ocean water closer to it and creates a bulge near land. And as it becomes more distributed across the ocean, it begins to drop down. And so this is one of the major factors that we look at when we're looking at sea level change. And so for some places, like around here, this isn't as big of a factor anymore, but if you go to somewhere like Alaska that still has a lot of ice, it becomes a major role in how we calculate that sea level change around the globe. I also want to talk about the thermal expansion of water, because obviously things are getting warmer. And all those little molecules of water in the ocean, the way we measure the heat is by measuring how much those are bouncing around. And the more they bounce around, the warmer they get, and they want to expand. So if I took everyone in this room and I told you all, okay, everyone come stand up here, stand nice and still, it's great. We'd probably all do that. Then if I told you to start running around, you'd all start bumping into each other, and you'd say, nope, I want to start moving down the aisles. I want to get out of this room because I want to stop bumping into people. All those little water molecules, they're doing the same thing. And they take the path of least resistance, which in this case is up. And so when you think about the sea level rise around here, those are kind of the two things that I want you to think about, is that thermal expansion, all the water molecules bouncing around faster and faster with the heat, and then all of that water flowing into the ocean. And humans are curious. We like to figure out how things work. That's why you guys are here today, hopefully. But we start to measure that change in sea level. And here you see some of these blue lines. This was back starting in 1970, and let's see if this will play for me. Yes. And so we measure year over year. And as these lines get progressively more red, it's showing the sea level. Right up until right about today, where between 1970 and today, we saw about 8 inches of sea level rise. And that's right here on Cape Cod. And so this is a problem that many of you are probably familiar with. And as you probably know, it's going to keep going. Scientists, we don't have a crystal ball. I wish I did. I'd probably make a lot more money that way, but we can't predict the future, and we try to figure out what's going to happen. And so you've probably seen this before. All these lines looking at how the sea level is going to change into the future. And these are our projections. So whether it's going to be maybe not so bad, or it's going to be really high. We're trying to solve this into the future, but our best estimates right now show that we're looking at about 3.9 feet of sea level rise between 2000 and 2100. That is a tremendous amount of water. And yeah, vertically you think maybe tides are bigger than that. But this is a new baseline for everything to work off of. And that water, as it gets higher up, it goes further inland too. And solutions like this, probably not gonna cut it. These are 36-inch doors, not enough for almost 4 feet. But I want to look back to that thermal expansion, that heat in the ocean, the water molecules. Because as the ocean continues to warm, and you see here, 2025 is the orange line. This is where we are right now in 2026 with these little dots. Those are the preliminary results. So don't trust those quite yet, but that solid red line, that's what we're measuring globally right now for the average sea surface temperature. And it drives this. Hurricanes love heat in the ocean. It's what fuels them. And so as we continue to increase that heat, we're very likely going to see more powerful hurricanes. And in some cases, we already have. Now, you may not necessarily see more storms, but the storms that we do see are going to get stronger, and we're going to see the major hurricanes, those category 3, 4, and 5, those are going to become more frequent, and with that added strength, the likelihood of them coming to Cape Cod starts to increase. And that's a problem because hurricanes are a huge storm. And so if you're driving on Route 6 at obviously going the speed limit, 55 miles an hour, and you put your hand out the window and you feel the strength of that wind, hurricanes are already 20 miles an hour faster than that. That's a category 1 hurricane. As we go to categories 3, 4, and 5, what we refer to as major hurricanes, the destruction that they can cause can be catastrophic. We are talking about entire neighborhoods that are uninhabitable for weeks or months after the storm. And I know what you're all thinking, Brian, we don't see hurricanes, we see nor'easters, like we did back in February. And these storms too can have hurricane force gusts. So back on February 23rd, you see this satellite image from NOAA. This storm took up almost the entire East Coast, and it brought with it, I'm sure you guys know, a couple feet of snow with it. This was a major disaster on Cape Cod. We had emergency shelters open. We had people who couldn't leave their homes for a week looking to get groceries. And so these are some of the things that I try to get people ready for. And if you're ever curious about that difference between hurricanes and nor'easters, I don't have time to dive into it today. Not much more than I did, although if you ask questions, I'd love to talk about it. But we have a technical bulletin that we put out that goes through the details of how each of these form, where they form, kind of how they act in the environment. And like I said, all of that sea level rise, it gives these storms a higher baseline. And they bring with them storm surge. And that is the elevated bulge of water that goes beyond the tide. And it can be critical for the timing. Because if peak winds are right at high tide, like you see here, it can become the new storm of record. And so what you see here is from this is March of 2018. But January of 2018, the water level actually surpassed that of any other storm before because the timing was perfect. The peak storm surge aligned with high tide and brought with it a new record. And sometimes timing doesn't matter because you can see that the storm surge for March, it lasted for days and days and days. The storm stuck around and it kept driving that water onto the coastline. And this becomes a huge problem for anybody, really anybody that lives on Cape Cod. And it also depends on whether we have spring tides or neap tides. So spring tides are when the sun and moon are out of alignment. They're almost pulling at a right angle to each other around Earth. Neap tides, spring tides, that's when the sun and moon are in alignment with Earth and they start to pull in the same direction. And so you see these larger tides. This becomes a critical factor when we're tracking storms as well. And this is not a tidal wave. This is a tsunami. And this isn't caused by a storm. This is your tectonic plate shifting. Again, I wish I had more time if you guys had me back here and go into this in a lot more detail. But it's one of those things that if you talk to the scientists and you say, oh, it's a tidal wave. Well, no, it's not a tidal wave. But the last thing I want to talk about are wind waves. And that's kind of what we think of day to day as waves. It's the ones that are running up on shore, running back. And one of the first things we want to look at is the fetch, or that uninterrupted distance over which the wind can blow. And so when you're looking at a small inland pond, there is a little bit of fetch. It's pretty short. If you're looking at the entire North Atlantic, that is a long runway for these storms to keep building waves. And as the wind speeds pick up, you're going to start to see higher waves. And as that wind blows for a longer period of time, you start to see longer waves. And these combine to create a lot of erosion on the coastline. And when we look at waves, we always hear about a wave height. And we know that waves don't really look like this in the ocean. They're not this clean, they're not this smooth, they're a lot more dynamic. But when we look at wave heights, we have the maximum wave height. So that peak, highest, top wave, where that gets to, but we also have the significant wave height. And that's typically what you're gonna see when we talk about the wave heights in the ocean. And the difference there is that the significant wave height is the average of the highest 1/3 of all waves. And so if you look at all the waves during a storm, and you take that biggest 1/3 and average those out. And this can look incredibly different. So back in January of 24, we had a nor'easter come through, and down off of Block Island, there's a wave buoy. And that maximum wave height was 55 feet. That is a vertical change that is almost incomprehensible to us. It is a building, but the significant wave height was 24.6 feet. That is still an incredibly large wave. And this is what is coming onto our shoreline. And as they move in, these waves start to interact with the seabed. And that's where we start to see the sand shifting and some of that erosion come through. And so now we're finally onto the beach. We're looking at the sand, we're looking at the sediment, and there is a lot going on. There's wind blowing some of the finer grain material around. There is erosion of banks and dunes. There's vegetation trying to hold on to that sediment. And these waves don't always come in perfectly parallel to the coastline. They're coming in at all kinds of odd angles. And day over day, they start to create currents along the shoreline that start to move the sand in kind of a net positive direction. And we see that all over Cape Cod. And so you see, I was talking with someone in here just before this. If you look over at Sandwich, that sand is moving out towards Sandy Neck. If you go out to the outer Cape beaches, a lot of that is moving down to Monomoy and out to Provincetown. And it moves a lot of sand. So 3,000 years ago, Sandy Neck didn't really exist. It's that sand movement, littoral transport, that drives these new features to be created through time. And so we often think of erosion as a bad thing, but it's more of a natural thing. It creates a lot of beaches, it creates landforms, and it creates habitat for a lot of the things that live here, including us. And you see this play out in the data we collect today too. Here you see LiDAR elevation data from Truro, Provincetown. And this red you see here, this is much higher in elevation. This is about 100 feet high. The blue that you see, that's much lower in elevation. And that's the difference between the wind, the waves, the littoral transport, and what was brought in by the glaciers. And so we start to tease out some of these intricacies in how the coastline is working based on this kind of data. But as you guys know, it doesn't always take 5,000 years for the beach to change. It's really changing with every wave that we see every day. And you see this a lot seasonally too. And so in the winter around here, that's when we have our nor'easters, and that's sending in bigger, stronger, higher waves that are reaching up further on the beach and moving more of that sand. And it starts to flatten out a little bit. In the summer, we have lower energy waves. There's not as much wave reflection back off the beach, and it starts to build up that sand little by little. And so you can see an incredible change just in the seasons around here. And this looks awful, I know, but this is one of my favorite things that I work with. And this is the Wentworth scale. So when we talk about sand, it is actually a very well-defined range of grain size. Below that, you have your silts and your clays, that really fine-grained sediment, all the way up to your pebbles, your cobbles, and your boulders. And this becomes incredibly important because when I go and talk to other scientists around the world, when I talk to engineers, when I talk to construction companies and homeowners in towns, defining exactly what is on the beach and maybe what we want to put there becomes very important for maintaining these habitats. But one of my favorite columns on this graph is this last one here. And it is the threshold velocity for traction in centimeters per second. I know. But basically what that is saying is how fast does the water have to move to start to mobilize that sediment? And so this works out to be pretty intuitive, where the larger the grain size gets, the faster the water has to move to start to move it. But we have this strange region back here. Anybody have any idea why it becomes harder to erode some of those silts and clays? So they are so small that the surface ions actually start to create cohesion between them, and so it can be harder to erode some of the finer grain materials even with a higher water velocity. But it works out to this and this. Everything that I just told you comes back to us, living on the coastline, in our homes, in our lives, in our jobs. And this obviously isn't a good thing. Somebody lives here. So we try to fight that erosion. We have tried to employ different strategies like revetments, the large rock walls you see, gabion, the almost lobster baskets full of rocks and shells that you see people build up, and then things like fiber rolls you see a lot. That coconut fiber that's wound up really tight into logs and then packed into the beach. We're trying to slow down that erosion to protect our homes. But this also comes with adverse consequences. So when you look at a beach and you look at any what we call a coastal engineering structure such as this, we can see that the direction of net sediment transport, those waves coming in at odd angles, driving that current, it's moving from right to left here. So that sand is trying to get around. It's trying to get over here, but it can't. And so this is habitat that we have changed, and it's not necessarily great for the habitat. So we came up with a bunch of regulations on where, how, and when we can employ these strategies. And that's all wrapped up in the Wetlands Protection Act. And I love regulations, but I admit they're kind of boring. That's why this is my most boring slide. There's not a single photo here, but they become incredibly important in how we interact with the coastline, because we are trying to balance not only maintaining our lives, our homes, but also the habitat, everything that lives there. The beautiful beaches that we see, that's because of erosion. And we use those soft solutions, those fiber rolls, and we think, great, it's natural. But these aren't necessarily permanent solutions. They can start to break down over time, and they may only last a year. They could last a decade or more. If they do, you may have put them in the wrong spot. But we try to use these nature-based solutions to work with Mother Nature. And all of these, they interrupt that natural flow of sediment. And so if you ever employ one of these, the town's probably gonna tell you, you're gonna have to bring in sand to put it back on the beach to try to maintain that natural flow of sediment. And sand is very expensive. If anyone in here offered me a gold bar or a dumpster full of sand, I would probably take the sand right now. It is incredibly expensive. And you're not gonna fool Mother Nature. So as we put these in, you can see wave reflections and refractions around these installations. So if you ever look at the end of a revetment and you see it scours out right at the end worse than it does anywhere along the beach, it's because those waves are bending in around it and they're increasing the erosion rate. And when they hit that hard surface, they bounce back off. And so you may be stopping the erosion behind it, but you're very likely increasing it on the other side as well. So like I said, you can work with Mother Nature. Things like salt marshes, our long, flat beaches, they help to dissipate wave energy so that when something like this comes in, we're protecting the coastline, but maintaining that habitat, maintaining the natural systems, maintaining the beautiful beach that we love to go to in the summer. But Brian, I don't live directly on the coastline. Not all of us are that fortunate to have waterfront property, but a lot of this still impacts you. Because we talked about that water getting higher, going further inland. And so even if you're not right by the water, your chances of flooding are still going up. And we tell everyone, wherever it rains, it can flood, because that water does not care. So you can find out your risk by this handy website from Coastal Zone Management. And I want to focus in on two of these sections here. One is the FEMA flood maps. So some of you are probably familiar with this, and you probably hate these because the town said, nope, you have to build your house at a higher elevation, or you have to elevate your utilities, or you should really have flood insurance because you are within a V zone or an A zone. But what this tells you is kind of your risk of where that water is going to get to. But one problem with these, actually I have two problems with these. One, it's all hindcast. It's looking at storms that have already happened and saying, okay, this is where the water gets to in a storm like that. And the second problem is these are lines on a map. Water does not follow lines on a map. So you really shouldn't trust this exact line right here. And really the only time you should is when it's your property boundaries. Don't pick a fight with your neighbor. Those lines you should trust. But water, it can go beyond these. It might not ever reach these, but this is all looking backwards. We also have the Massachusetts Coast Flood Risk Model, or the MCFRM. This is looking into the future. This is looking out to 2030, 2050, and 2070, and trying to incorporate that rising sea level and that increasing storm intensity to say, okay, this is where we think that water is going to get to. And it will tell you what that water depth is going to look like in one of those storms. And so when you're planning things out, the FEMA maps are regulatory. You have to use those. But it may be a good idea to take a look at this as well, because if you're going to make major renovations, elevate your house, thinking into the future is always a good plan. And if you don't live right on the coast, well, if you guys were here in February, you know that these coastal storms are wicked. And so it's good to be ready just in case. I was helping to operate some of the shelters for Cape Cod during that storm, and it was literally a disaster. We had people showing up who were unprepared. They didn't know what to do. They didn't know where to go. And I want to try to get people ready for it. And so having a go bag ready, I I didn't bring mine today, but I genuinely have one that I keep with me all the time. There's 2 cans of beans that I do swap out, but things like your medication, that's one of the most important, because people forget that all the time, and you may not be able to get back to your house to get it. But food, water, flashlight with batteries, first aid kit, these are the things that you should have ready and at least have an idea of where they're at. And then that way, whether you're going to an emergency shelter or you're just staying put in your home with no power, no electricity, no heat, it's good to have this stuff ready so that you can be prepared for anything, because the weather is incredibly unpredictable. And we also have a whole checklist of what to do if you're staying at home, if you're going to evacuate, or if you're going to a shelter. And a lot of that is, oh, not yet, give me one moment. We also try to get your house ready. Things like hurricane ties, where you're tying your roof to the walls and you're bolting these in to try to help as that wind stress is pulling up on the roof to keep your house together. And all of that is wrapped up here in our homeowner's handbook. There are a bunch of these down the back, and I love this thing. I try to give it to everybody. Not only is it a nice book, it just feels good in the hand, but it runs you through the hurricanes, the nor'easters, how to prepare yourself, how to prepare your property. And it even gets into one of the things that I try to avoid, so don't ask me questions about it, but insurance. And beyond that, scientists are pretty busy. We are trying to be everywhere all at once. And so you guys can help us out too by using things like MyCoast and CoastSnap. So MyCoast is a phone app that you can use to actually document storm damage. And I have it on my phone all the time, and after a storm, I'll get a call from the state and they'll say, hey, can you get to Surf Drive in Falmouth? Can you get to Orleans? Can you get to Sandwich? We want to know what's going on there. But I'm only one person, and it's really tough to get all the way around the Cape in just one day. And so if you guys, whenever it's safe, can get out and document some of these using this app, that's good data for me to figure out what this storm actually looked like on the ground. And then not only that, we have CoastSnap. And you can see an example here. It's a post where all you do is you throw your phone in, take the photo, you scan a QR code that's going to be right on the sign, and then you send it in to us. And this isn't necessarily for storm damage, although it's great if we get before and after, but it's tracking that sand movement through time. That day over day change, that little by little that we look for, it's something that's really hard for me to keep track of on my own. And so I ask you guys, I ask the public for help in that same thing. But with that, I just gave you guys a ton of information. Hopefully it was good. Hopefully it isn't terrifying to you. But I'm happy to take any questions that you might have. Yeah, we got one down the back.
Yeah, is this video going to be online for people who could not make it today?
Yes,
It's so full of information.
yes.
Yeah, I believe it will be online, yes.
At ALL?
At ALL. At ALL, it'll be on our website, it will be on our YouTube page, and maybe on our Facebook page, I'm not quite sure. It will also be in our next newsletter.
Do people or towns contact you about mitigation and things that you should be doing? It seems like when I live in Sandwich, it seems like we do things, and I just wonder if there's actual science behind some of the stuff that we do.
Yeah, so the question was, do I work with towns to try to help bring some of the science into their projects? And that's kind of my primary job. I work with pretty much every town on the Cape, the islands, and even some along the south coast, along the south shore. And we talk about some of the projects that they're doing, and we try to inform what they're planning with the science, with these projections. And I will say the towns are pretty good. They are on top of these things, maybe more than you think, but it's always a balance between maintaining infrastructure and trying to keep things in place and preparing for the future. And it would be great to say, oh, this road is gonna be underwater in 20 years, let's bring the whole thing up. But that's often triple, quadruple, 10 times the budget that the town has to maintain that infrastructure. And so it's always, with many things, trying to find that happy medium. Yes?
You mentioned that sand is very expensive and we're replacing a lot of beaches with sand. Where does the sand that we're replacing come from?
Yeah, so where does the sand come from that we're putting back on the beaches? And some of it is from upland mining. So a lot of cranberry bogs used a lot of sand to cover the cranberries in the winter. We can sometimes use some of that to get back on the beaches. There are upland mining pits that we pull sand from. We also use dredge spoils. And so when you are dredging out a channel, trying to maintain the depth there, a lot of that actually ends up back on the beach. One of the problems that we run into is you have to use clean sand. And I always kind of struggle to wrap my head around that. What is clean sand? But we're looking for maintaining that grain size and also looking for different chemicals, different marine debris, things that are in that sand that we don't necessarily want up on a beach. And so a couple different places that it comes from, but it is a finite resource. And that's why it becomes so expensive, because you need the right stuff and you gotta get it in the right spot. And that can be very tough to do. Yes?
I read that scientists are concerned about the Greenland glaciers melting, and how is this going to impact the sea?
So the Greenland ice sheet is melting. That is, we are seeing a loss of ice, and like we talked about, a lot of that water is flowing into the ocean, and so that is elevating the sea level. One of the things that we're really looking at is how fast it's melting, and again, trying to predict into the future what that's gonna look like. And it's not even just the sea level, but it's the ocean circulation that we're looking at as well. That there's a lot that goes into that, and it is a very complicated problem, but it is a problem because it's rapid change that is accelerating. And so we're doing a lot of work on that. I hate to tell you, not necessarily my expertise. I've never been to Greenland, although I would love to go. But if you'd like, I can get your email after this and send you a bunch of information from a lot of the scientists at WHOI that do work on this stuff, and they know a lot more than I do, and they are very good. Absolutely. Yes?
The fact that the Greenland ice is melting, that's fresh water.
Mm-hmm.
When it goes into the salt water, it loses salinity.
Mm-hmm.
Is that, I'm not sure, I think I've read that can change, like where the water goes, and, trying to think, what's that, warm water that goes up the coast?
The AMOC, the Atlantic Meridional Overturning Circulation.
Right. Does that affect that?
Yep, and so the question revolved around fresh water from the ice sheet going into the ocean, which is obviously much higher salt content. And one of the things you see is different densities between that fresh water and the salt water. Salt water has dissolved ions in it, it's gonna be more dense, and so that fresh water will almost float on top, and it does cause problems. It's something that we're looking into to try to figure out what that ocean circulation looks like into the future, and I'm gonna do the same thing of more questions, more details. I can certainly get you the answers, but I don't want to get myself in trouble today with telling you the wrong thing.
Thank you.
And sorry, we have one over here, and then I'll come back to you.
It seems like Sandwich, Chatham, a lot of other places, every year we put in new sand, and every year the sand goes away, and we have the same problem. Is there a point at which we say, we don't do this anymore?
There is. And where that point is very complex, because it's not only the natural system, it is the economics of it. It is the infrastructure. It is all of this tying together into what sometimes becomes politically charged decisions, not just science-based. And one of the things that we look at, you know, are the fiber rolls, the revetments, adding more sand. One of the things that we're starting to have the conversation about is, it's gonna sound really bad, managed retreat, because who here wants to be managed by the government? Exactly, and who here wants to retreat? Yeah, it's nobody wants to be managed, and retreat sounds like failure. But the problem is some of these coastlines are going to be unsustainable. As that water comes up and the erosion increases and we can't get more sand on the beach, for some locations, we are gonna have to let them go. And problem is, the people that live there, what happens to their property value? What happens to that tax revenue for the town? Where do they go? And how does that change the community that they end up in? And so these are questions that we're looking at, and the state is actually working on a buyout study right now for the people that live in the most vulnerable areas, because you could sell your house, but if you sell it to me, now that's my problem, and I have to figure it out. And if there is no good solution for that area, then I get stuck with it. And a lot of this you may have seen with houses that used to be millions of dollars and now are selling for maybe $100,000, because that area, we know that it's gonna go away, and that property very likely won't exist in 20, 30, 50, 70 years. Oh, sorry, let me jump over here first.
You mentioned that AMOC, the Atlantic Meridional, is that what it,
Yep.
Meridian, isn't that affected already? I mean, it's slowing down, the Gulf of Maine's being impacted.
Yep, and so these changes are not new. These are things that we have been seeing for a very long time. And we try to track them, and we're trying to use what we've seen to inference into the future. But, right, that it is slowing down, and part of that is leading to the Gulf of Maine being one of the fastest warming bodies of water on the planet, and that is influencing our fish populations, our shellfish populations, that thermal expansion. And so it is, one of the interesting parts about my job is how complex it is. You get to, you know, things that are happening in the Pacific are influencing what's happening in our own backyard. But that also makes it really tough to figure out exactly what's going on. But it sounds like you guys have a lot of curiosity about that, so I'm gonna go find a bunch of good information, and then I'll get it to you guys, so when this video goes up, you can have all that right there with you.
I'll also add too, so the Oceanographic just, within the last several months, launched the Ocean Learning Hub, and there's a flyer in the back that I put with several like infographics for, yes, here it is. If you don't mind me, I can grab it. This here that I just quite crudely put together last night before I left for work. But it's called the Ocean Learning Hub. You can even write this down. It's right off of our main page, WHOI.edu, WHOI.edu. You can search for any topic that you're interested in, and it will search within the Oceanographic's scientific papers and more educational papers as well, along with infographics and videos, everything that we have accumulated since the dawn of internet time is in here, and we're improving it, you know, monthly actually, as we also write more information too. So it's a fantastic resource. It has information on the AMOC, it has information on coastal erosion, it pulls information from Sea Grant, from a ton of other resources that we publish too. So pretty much every single thing that you could possibly want to ask about the ocean, because that's what the oceanographic does. We research everything that has to do with the ocean. There's a lot of information there, so I turn it back over to you. Yeah.
Yeah, thank you. That's really nice to know because I am hyper-focused on the sand in our backyard, and that's why it's tough for me to answer a lot of these wider questions, but yeah, we get the folks who do have those answers, so great resource, thank you. Any other questions? Yes?
Ryan, we talked before, and I'm down the street from First Beach and then Town Neck's around the corner, and the Army Corps of Engineers, they blew a lot of sand in, and as you know, there's not as much left already because of the 2 storms they had this winter. And on Facebook, a lot of the town people who don't live near the ocean complain about all the money that's being spent and things to be. And sand doesn't seem to be working. Why can't we do some of the stone, the boulder, I think you call it revetments? Because a lot of people ask that question and no one ever seems to have an answer.
So, the question was looking at Sandwich in the Bay, a lot of the erosion. Why don't we use more stones to shore up that coastline right there? And part of the problem is what I got into a little bit of those adverse impacts. So one of the problems is that those stones are what kind of created that problem to begin with the canal. They cut off that sediment transport. And so if you go to the updrift side, on the other side of the canal, you see an accumulation of sand. As you go across to the downdrift side, that sand isn't making it there anymore. And so why not put rocks there to help that shoreline stay in place? Well, it's losing sand at an incredible rate. You've seen it. If we put more stones there, you're going to increase that reflectivity of the beach. You're also going to destroy that natural habitat that's there. And so it's almost like adding on to an existing problem. And with how fast that changes and how dynamic of an area that it is, it would be tough to say how long that would actually last before it goes to the end of the rocks and starts eating away there, and then it just cuts in behind. And so, could we? Yes. But should we is a far more complicated answer. Yep. Yes.
In regards to the same area, Town Neck Beach and Sandwich, is there anything that can be done with the canal itself that can redirect the flow of the sand?
Yeah, so the question was asking if there's anything we can do with the canal itself to help reestablish that natural sediment transport. And yes and no. So one of the things that we could do is consistent dredging on the updrift side and move it back over, kind of like what we did at the end of 2024, the big renourishment project that happened. That is extremely expensive. It is, I forget the exact number, was it around 10 million that they spent to bring that sand around, and it was about 300,000 cubic yards that the Army Corps of Engineers paid to have it brought in, and a significant portion of that is already gone. So we need something a little more consistent. And they do have pumping stations where you can move sand from one side of the canal to the other. And you see this a lot like down in Florida, where they do major sediment movement projects, major dredging. They have some of these pumping stations to move that sand along more naturally. They're out of commission very frequently because it is really tough to do. You're mixing seawater and sand and pumps and a lot of mechanical machines that are prone to failure. And again, it becomes an economic problem of it becomes so expensive. And so where does that scale land? Tough to say. The other solution that I've heard people say is, well, get rid of the canal entirely. But again, that is shipping traffic that goes through there, because if you have to spend the fuel and the time to go all the way around Cape Cod, it becomes, again, an economic problem. And so, are there solutions? Yes. Are there economically viable solutions? None that we really have right now. Yes?
I have a question. Sorry, I was late. I was teaching a class upstairs, and you may have already addressed it, but did you address the life expectancy of Cape Cod given the rate of erosion as it is now?
Life expectancy of Cape Cod, given the erosion. So what I will say is the vast majority of Cape Cod is not really going anywhere anytime soon. It is a really big chunk of land, and to eliminate all of Cape Cod, we are looking at tens of thousands of years. And so to give you an idea of the scale, we looked at, you're not supposed to do this, but I'm gonna do it anyway. Sorry if this makes anyone a little motion sick, but we're gonna go back to that, the letter elevation between Provincetown and Truro. Yes, this one. So this red was brought in about 18,000 years ago with the glaciers. All of this blue beyond it, that's all the sediment transport and erosion after the fact. And so when you look at the scale of those glacial banks that, sediment that was brought in by the ice sheet, it's massive. And then Provincetown took up until today to build out. And so even if we do lose many portions of the Cape, if this keeps happening, we're building new ones too. So erosion doesn't necessarily mean that the sand is gone. It just means that it's going somewhere else, maybe not where we want it to. But for the Cape to be entirely underwater and everything to kind of go away altogether, it would take, probably hundreds of thousands of years.
Okay, so these articles about it, Cape's here for 50 years to 200 years, no.
Yeah, so you are gonna lose many important factors of the Cape. A lot of the low-lying areas are gonna end up underwater. But the Cape as a whole, it's gonna be around for a long time. And so it's working with the people that are gonna, gonna be underwater. Where do they go? Do they stay on the Cape? How do we create more space for them? How do we increase the housing density? Because at the same time, we want to try to preserve a lot of our conservation land so that we maintain the habitat for birds. And, well, some people don't like the deer these days, so I'll stay away from that. But it's a big balance. But the Cape going away entirely, it's going to be a very, very long time, and certainly not in my lifetime.
Thank you.
Yes?
As we lose more land to the ocean, what does that do to the one aquifer we have? Is the salt infiltrate?
Yep, so asking about the sole source aquifer on Cape Cod. So sea level is coming up, and that does mean that the water in the land is going to come up a little bit with it. What that means right now is still a little bit uncertain. We're actually working with some folks at WHOI and along with Mass TC to see what that saltwater intrusion looks like into our septics and aquifers so that we can get a better idea of what that means for our drinking water and all the septic. But it is coming, so.
One last question.
Yep.
Someone told me that eventually we're going to need another bridge because the land between Marconi Beach and the bay is going. And it'll be underwater at some point. I don't
So, are we gonna need more bridges to span other places on Cape Cod? And probably yes. What that timeline looks like is tough to play out. Depends a lot on sediment movement and the infrastructure, but the Bass River is one place that is a concern because it goes so far through the Cape and it's shallow all the way through. And then the Pambit River up in Truro, where that is overwash at Boston Beach, down to the river, and then all the way out to the bay. And so as that sea level comes up, if there is not enough sediment to maintain that elevation, then we may see more consistent flooding or just open water right through there.
Is this within our lifetime, like Bass River?
Probably not. Is the water gonna get there to that elevation? Not unless there's a major storm and that water is really cooking up through there, probably in like 2070. You can actually, I don't wanna do it again, but you can actually go to that Massachusetts Coast Flood Risk Model and see that during the 2070 1% annual chance storm, the water can get all the way through. And so, a consistent river, probably not in our lifetime, but could water make it all the way through? Yeah. What that looks like, you know, on the ground is gonna depend on the infrastructure we put in place to try to combat that type of thing.
So it's gonna erode either side of the river banks.
Yeah, so as that water's coming up, you can get more tidal flux going in and out. And so you might start to eat away at some of those banks. And there are some people out there that would argue we don't actually have rivers on Cape Cod because there's no upland source. And so there is, one of the downsides is there is no more sand on Cape Cod. We can bring it in from upland sources, but we're not like the Amazon River where we're bringing a bunch of sediment out to the coastline with it. And so it becomes tough to balance that as you see more flow velocity go through.
Well, I think we'd like to thank Bryan tremendously for what he gave us today, what he will send us, and what we will be able to send to you. We thank you so much for coming.